This afternoon, our module or our word problem is about uniform motion. What do you mean by uniform motion? If you say motion, it means how fast an object is moving. Now, there are three terms to deal in motion. We have distance. Distance will ask you how far. Next is the rate. It means how fast. And T is time, how long. So if you're looking for distance, then we will have this first formula. If you're looking for rate, the second formula. And if you're looking for time, you will have the third formula. Now, how are you going to solve motion problems? Here are some tips. Number one, you need to make a 4-column table like this one. In the first column, we have the moving objects. In the next column, we have the rate, then the time, then the last is the distance. We just need to fill out one column based on the given. Then the next will be done through the formula, like these formula on top. Now, let's start with problem number one. Let me first snip that. Problem number one is asking, the distance from Manila to Baguio is approximately 250 kilometers. If cars A and B are both coming from Manila and are going to Baguio with speed rates of 60 kph or kilometers per hour and 65 kilometers per hour respectively, then how many hours will each car take to reach Baguio? Now let's start with our table. Again, we need to make a 4-column table. In the first column, we'll have what are the objects that are moving. The next column is rate, then time, then distance. We start by asking ourselves, what moving objects are involved? If we read the problem again, we know that we have cars A and B. Therefore, our moving objects are car A and car B. Next, we fill out only one column. So let's read first the problem. Both cars have speed rates of 60 kilometers per hour and the other is 65 kilometers per hour. So it means that if you say respectively, then the first one belongs to car A and the second one belongs to car B. So we say that the rate of car A is 60 kph, while the rate of car B is 65 kph. Now what is missing? Let's read the problem again. Then, how many hours? Hours is for time. So we say that time is missing. So we say let X be the time. We write X and X. So now, let's go to the distance. How to solve for the distance? We go back to our problem. Remember the formula? If you're looking for distance, that will be rate times time. If you're looking for rate, that's distance over time. If we're looking for time, that will be distance divided by rates. So we will be using the first formula, rate times time. So 60 times x, that is 60x. 65 times x, that will be 65x. So our table is now complete. Next, we write the equation. Let's go back to the problem. The problem says that the distance from Manila to Baguio is approximately 25 kilometers. Therefore, if cars A and B are both coming from Manila, so it means that here, if this is Manila and this is Baguio, then car A is moving from Manila to Baguio. This is car A. Car B is also moving from Manila to Baguio. This is car B. So we say that the distance of car A is the same as the distance of car B. And remember, the distance is approximately 250 kilometers. So let's solve. For car A, we have the distance of car A, this one, is equal to 250. Divide both by 60. So our answer is 250 divided by 60. That is 4.17. Remember, x is for time. So we say 4.17 hours. If you'll be solving for car B, that's the distance of car B, that's 65x equals 250. Divide both by 65. So our x is equal to 3.85 hours. This is now the answer to our problem. Again, the question, how many hours will each car take to reach Baguio? For car A, it will take 4.17 hours, while for car B, it will take 3.85 hours. Now let's go to the next problem. Let me first snip that. Now, in problem number 2, it says, a van leaves Manila traveling towards Legazpi City at 64 kilometers per hour. This is for the van. A car leaves Legazpi City traveling towards Manila at 56 kph. And Legazpi City, Manila and Legazpi City are 480 kilometers apart. How many hours? We're looking for the hours. Will it take them before these two vehicles meet? Now let us start. Let's start by drawing the table. The first column is for the moving objects. The next column is for rate. The next column is for time. And the last column is for distance. Now let's solve. What are the moving objects? We have the van and the car. So let's write the van and the car. Now, what are the given? It says the van moves at 64 kph. kph stands for kilometers per hour. Therefore, it is a rate. So let's write 64 kph for the van. How about the car? The car is moving at 56 kph. Now then stop reading the problem. What is being asked? We're looking for hours. That's time. So we don't know the time. We just write x and x. Let's solve for the third column, the distance. Remember, distance equals rate times time. So 64 times x, we have 64x. 56 times x, we have 56x. This time, we are going to write our formula or our equation. Now, let's first draw the problem. Here, example, this is Manila, and this one is Legazpi. Remember, the van is traveling from Manila to Legazpi. So we say the van is traveling towards this direction. That's the van. While the car is traveling from Legazpi to Manila. This is the car. Now, how do we describe the distance being covered? We say the distance covered by the van plus the distance covered by the car, if they will meet at this point, is equal to the total distance. Why do we need to add? Because two objects are meeting. Again, if two objects are meeting, we add. If two objects are of the same direction, we equate equal sign. Now, what's the distance traveled by the van? That is 64x. What's the distance covered by the car? That is 56x. And what is the total distance? We have 480. This time, we will solve for the value of x. 64 plus 56x is equal to 120x equals 480. We divide both sides by 120. That leaves us x equals 4. We go back to our table. What is x for? It's for time. So it's written in hours. So we say that x is 4 hours. Let's go back to the question. How many hours will it take before these two vehicles meet? Our answer is in 4 hours, the van and the car will meet.